So today we are going to revise the graph and all the details we can extract from the second order underdamped system. So this is the graph of a second order underdamped system having step input. So we know that the city will try to settle at the value of steady state, or we can call it the steady state is equal to input constant parameter multiplied by dck. So if the steady state is ak, then from the graph we can see that the response is trying to reach the value of ak and settle it. So I have magnified it a little bit so that what we want to achieve about the graph can become more easy. So the first thing we will talk about, that is in the time domain. So in the time domain, we need to know basically three things. First, at what instance of time the ct becomes equals to the value of steady state, that is ak. So from the graph we can see that there are four instances, 1, 2, 3, 4, where the value of ct is equals to ak. So this video is a short revising, and so we will only use formulas. So for that, the formula of the time is k pi minus phi divided by omega d. You must be familiar with omega d. Omega d is equal to omega n under root 1 minus zeta square, and the value of phi is cos inverse zeta in radians. So if we know this formula, we can get these four time instants where the value of ct is equal to ak. K is 1, 2, 3, so on. So this is the first time when the ct is getting equals to ak. So we put the value of k equals to 1, and the time will come to pi minus phi divided by omega d, right? For the second time instant, at this point the value will come to be, putting k is equals to 2 because of the second time, so it will be 2 pi minus phi divided by omega d. This is the third point, so the value, you can assume that you have made this is 3 pi minus phi divided by omega d. And for this fourth point, this is 4 pi minus phi divided by omega d. So this is the first thing we have to know in the time domain about the time instance where the value of ct becomes equals to ak. Now if you can notice, the T1 and this T2, what is this T2 minus T1? The T2 minus T1 comes equals to pi upon omega d. Now calculate T3 minus T2. That is also pi upon omega d. And same in the case of T4 minus T3. So the value of del T is equals to pi upon omega d, where the what is T? T is the different time instance, successive time instance, where Ct becomes equal to steady state value. So I think that this part will become clear from this explanation. Thank you.